Good afternoon, and welcome to NRGene's webinar series. My name is Yael, and I am part of the marketing team, and I will be your host for today. In today's webinar, we'll discuss the advantages of genomic inputs in the agricultural value chain. Through the example of coffee plant development, we will present how genomics contributes to plant-based raw materials security and how genomics influences the agricultural supply chain to meet product requirements. At the end of the webinar, we will save some time for questions, so we encourage you to send in your questions at any time during the presentation by using the Questions tab on the left side of your screen. This webinar is being recorded and will be posted on our website in case you want to listen to it again. It's my pleasure to present today's speakers. We are honored to host a well-recognized expert in plant science, Dr. Vincent Pentillard. Vincent began his career in the industry in 1970, working on plant science projects for different companies such as Sanofi and L'Oreal. And since 1986, he has led Nestle's corporate R&D for plant sciences. Vincent played major roles in the foundation of Nature Source Genetics and Tropic Bioscience, companies involved in genomics and plant breeding. In 2019, he co-founded the Plant Science Integrator to help food and luxury companies ensure security, traceability, and sustainability of their raw materials. Today, Vincent is also a member of NRGene's Scientific Advisory Board. Our next speaker is NRGene's co-founder, Guy Cole. Guy manages NRGene's long-term strategic projects while helping shape NRGene's future products and offerings. His role is to identify potential strategic customers, understand their needs and priorities, and suggest specific business structures for possible partnerships. Guy received his bachelor's in science in computer science and biology from the Hebrew University of Jerusalem, his master's in human genetics from Tel Aviv University, and an MBA from Babson College. We will begin. Vincent, the stage is yours.
Yeah, okay, here I am, sorry. So good afternoon, everyone. I am very pleased to join this webinar organized by NRGene. I don't need to add anything to what Yana kindly told about me. So I just want to show you how much Genomic could help for the agro raw material that are used by the industry. If you consider food and beverages, everybody knows that a large number of crops are used for human food, either directly for human food or as ingredient. But according to what we know, 63% of the food production is based and relies on only 5 species that are mainly called commodities. But it's not only food and beverage product companies that are relying on key plant raw material, as we have mentioned on this slide: paper and pulp, flavor and fragrances, perfumes and cosmetic, and Yana told you that I've been working with L'Oreal and also pharma, natural rubber, textile. Many product companies are relying on the plant raw material and plant science. I have to say, Yana, could you shift the slide, please? Thank you. What are the first? I wish to remind you that, let's say 20, 25 years ago, plant science was not so much politically correct in the product companies, just because it was considered by the markets as commodities, and the industry of end products did not have to care about it. However, I had the opportunity to work even in product company at that time. What are the challenges faced by the product company for agricultural raw material? First of all, and I think it's very important, they have to secure the supply of plant raw material, at the right place, right price, and right time. And for many, many crops that we will see are called orphan specialty crops, it's not always very easy to do so. And if moving to new countries, new market, you cannot get the raw material in time at the factory, then you are out of the business for this new country. We also need to work on raw material for diversifying existing and creating new end product through exclusive, possibly proprietary, not always proprietary raw material. And that is the example I could give you from my experience with Nestle is new coffee varieties for special edition in Nespresso. You also have more and more to respond to consumer demands for sustainability, traceability, zero residues, and ESG criteria, as everybody knows about. As the consumer are increasingly concerned by all these issues, and they want to know more about the way a product company has used to purchase to supply the raw material they need from the growers. And that should not be forgotten. You have also to create some kind of knowledge databases or knowledge building, as I said very often, for customizing raw material for efficient processing and end product. Thank you, Yana. So this is just to show you the agro-food or agro-end product chain and that everybody knows. But the message here is quite clear. I think I wish to highlight that the breeding and seeds that are very often used for improving, thanks to this work of seed company, for improving the input traits, the performance for the growers, could also be used for improving the processability, either in primary processing or secondary processing, or some traits that are demanded or that are of interest for the retail, like shelf life, or for the consumer, like flavor. However, we have to be fully conscious that could be done directly for main raw material or indirectly through some ingredients. That's why I have mentioned earlier on the flavor and fragrances companies. Then you can see that there is a challenge, which is to achieve two ways flows information. On one hand, the information has to go from the consumer, from the product companies, to the breeders who are developing new varieties. But on the other hand, these new varieties have also to go through the whole chain and to be developed according to the need of the end stakeholder of the chain. I think it's very important. I very often said, how could you improve a processing tomato for a tomato factory producing tomato paste if you do not know how tomato paste is produced and what are the challenges for the company and for the industry? Could you go on? Yeah, thank you. Something I also wish to stress today, and I believe it's very important, these figures have been published 2 years ago in a book that is named Trends in Global Trends in Future for Agriculture and Crops and Food. And when you look to the seed industry, these companies are very much involved in R&D, very much involved for innovation. But if you look to the details, they are focusing on some crops, and even if spending 7.8 billion a year, of US dollar a year for the R&D and innovation and development of new varieties, that is very much focused on the most profitable crops at seed level, and they are not involved in many other crops that are important for the food industry. And this is why we call them orphan crops, like we call some diseases orphan diseases in the pharma industry, just because the pharma is not considering them with significant or paying to them a significant attention. So for these orphan crop like coffee is, but not only coffee, it is quite clear that the genetic innovation is very limited with regards to the importance of the crop. It comes mainly from public research, which is not bad, but for sure, in some time, that is provoking a lack of continuity due to political or economical changes, and especially for crops that are from tropical countries. On the next one, here we are. So why genomics could be part of a solution? I would say first, the main goal of genomic is to guide breeding, and that will be better explained by Guy than by me. But we, thanks to genomics and breeding, we can improve quality trait for the growers. And that is very important, even if a food company or an end product company has decided to improve a certain trait and succeed to do that, if they do not take into account the demands of the growers, and if creating a fantastic new coffee variety, for example, in terms of quality or whatever, if it is really poor in terms of quality for the growers, you will never find a grower to grow it. And for sure, we have to take first into account these input traits that are very important for the growers. Then on top of these input traits, we can look for what we call output trait of interest for the end product company, meaning that could be for food security, as I have mentioned. That could be for processing yield that will save you some cost. For example, if you can produce more end product from a certain amount of raw material, or if you could use less additive and processing heads, if you could improve the nutritional profile, flavor, color, texture, shelf life. I could give you a lot of examples with different crops on all these traits, but for sure, there are many possibilities to improve the whole chain for processing, retail, shelf life, and consumer preferences, thanks to the use of a specific raw material. The third domain where genomics is important is for sure the gene and trait, gene correlated to some trait discovery. Why? Because that could be used later on in the process of biotechnology, like GM, but also GE, that are quite rapidly developing now. And that also can be used as markers for quality control all along the chain. So let's talk a little bit about the coffee example we are supposed to discuss today a little bit more. So looking for coffee production today, we know that even if during this difficult COVID period, the consumption did not increase as much as it was originally expected, the best forecast estimation for the future of consumption is that we would need about 200 million bags. This is a unit of volume for coffee, 200 million bags per year in 2030. What is interesting to notice is there was quite big difference when I entered into the coffee business. There was a quite big difference in volume between Arabica and Robusta. What we could see today is Robusta is getting closer than Arabica from Arabica production than it was 20 years ago or 30 years ago. Then one has to look to the challenge for this production, and for sure there is a social challenge. It is claimed that there are about 100 million people who are living on coffee farm. And this is something to be considered, and this is certainly something that is considered by the consumers when they are looking for some labels or whatever it is. We also have to take care of preserving small producing countries' specialty coffees, meaning there are very, very good coffee, for example, in East Africa, that are progressively disappearing or decreasing in production, and that may be a challenge for the company. We have also to keep diversified source of production in order to avoid to create some kind of monopoly situation in one or two countries that would be challenging the purchasing people for getting the material they need, and also that could allow these countries to create some shortage situation, as we have seen that in the past with cacao and Ivory Coast, or as we could see that today with hazelnut in Turkey. We have also to try to limit import taxes in not self-sufficient producing countries. This is an example I have had to live with Mexico, that does not produce enough Robusta for what they need for the soluble coffee. Then there are also to look at the risk of climate change shifting possible growing area in new country. So all these challenges, I am talking in a general way, but should push the product company to take them into account and to look to the future. So I'm here summarizing the coffee production risk. I have already mentioned climate changing, and I'm talking now of climate warming, because as maybe you know, for a good Arabica, we need the growing area at a certain elevation in order not to have too hot temperature. In fact, what we believe is we need to have quite long ripening time for the beans to ripen and to mature and to produce all the precursors of the quality compounds after roasting. Obviously, and I did not, this is not a list of all the challenges for pests and diseases, but everybody knows about berry borer, coffee leaf rust, that is very, very important and has made a lot of damages 5 years or 6 years ago in Central America. Coffee berry disease, that is a fungus. Drought tolerance and water scarcity may be an issue also when considering Robusta in Vietnam. What we have shown already, thanks to some genomic work, is there is a very, very extremely low genetic diversity of Coffea arabica. We know why it is so low. It's because arabica is coming from the addition of two species, if I may say that way, that took place 10,000 years ago, and probably most of the arabica diversity we can see today and we have to deal with today is coming from one single plant or a very small number of plants, provoking a very low diversity. Then we have also to get back to the social issue, low profitability due to low yield in some cases, that is leading to low attractivity for the growers. So for a product company, and still keeping the case of coffee example, what are the possibilities for a coffee company? They can develop new approaches for product improvement, but most of them they have today is to create new blends or new coffee mixtures, new packaging, new processing, or even new concept. Has this capsule, that what we called in Nestlé when I was there, the concept of coffee per cup instead of coffee per pot. Why to have a longer term strategic investment versus a short term, where I just mentioned with new blends or whatever? First of all, because for coffee companies, coffee is a really important business. It is a core business. And as I was very often saying to my boss, how could you produce Nescafe without coffee? Okay. So then, is there alternative to coffee for coffee product? You know, there are some substitutes like the chicory that was introduced at the time of the Napoleon War, when the French could not import anymore coffee in the country. But it's still a good product, but it's not a substitute for coffee, even if it's still a quite important product in the area where people have been used to drink it. What has the potential for new product? Yes, there are maybe some, as I just mentioned earlier on, but not so many. That will be based on the blending or whatever. What has the potential for new process? There are some also, and especially when looking to soluble coffee, but that can be constrained by regulatory issue. So this is where the development of new variety could create a real new product and securing at the same time the supply of what we need. Coffee example, I just wish to go quite rapidly to 3 examples of coffee breeding, coffee project that would require genomics, to my opinion. First, it makes certainly a lot of sense to look for new Robusta with improved cup quality. I may be wrong, but I still believe that once we should be able to develop a Robusta as good as an Arabica and with a very nice cup profile. And as we have a lot of existing genetic diversity in Robusta because it is a cross-pollinated crop, it's not hopeless to believe that we could develop this kind of improved Robusta. We could also consider to recreate Arabica and a lot of Arabica diversity. As I told you earlier on, Arabica is coming from the addition of 2 genomes, one of Canephora and one of Genoides, Canephora, say Robusta. And that is interesting to say that if we look to the diversity, thanks to Genomic in Canephora and also to the diversity in Genoides, we could select 2 plants to be combined that are quite distant, that have a genetic background quite distant of the one you could find in existing Robusta today. And just as mentioned, I just got that in the media this morning. It sounds that Kew Garden, Dr. Aaron Davis, who is a very nice coffee botanist and coffee scientist from Kew Garden, just discovered or rediscovered Coffea stenophila, another species that would be more tolerant to quite high temperature, but still with a quite good cup quality according to what has been claimed. The only question I would ask for that is, would that be recognized, generally recognized as safe, or would that be classified as a novel food, meaning as it has never been consumed, the industry will have to go through quite a lot of toxicological and biochemical studies in order to use it. So more generally about genomic and breeding for a food company, I just wish to answer 2 questions. Why to go there when deciding we have to go for breeding and genomic when deciding to take a certain raw material into account or when facing a certain issue. And I believe we should not go directly for the most sophisticated technologies. There are quite good questions to ask ourselves before to start. And I don't want you to believe that I would propose to go directly to the most sophisticated approaches. First, you should ask yourself, is there not a substitute to the raw material with which we have a problem? I told you for coffee, we don't have it. Could we solve the problem we are facing with processing solutions, additive, whatever it is, even if the consumer are less and less appreciating the addition of food additives? Then I should ask myself, is there not no existing variety that could fit the demands we are facing? If there are some, why not to use them first? And if there is not, and we decide to enter into breeding, we obviously have to ask ourselves, are we capable to develop a reliable phenotyping system for a specific trait? For sensory, for example, are we sure our sensory phenotyping is reliable? If we have a new variety, could we rapidly produce and distribute on the large scale? That is not always obvious, and there are in coffee, but not only in coffee, quite a lot of examples where we have some good varieties that have never been used or distributed to the growers on a large scale just because we could not propagate them true to type. And at the end, obviously, the food industry, the food company has to ask how it will manage the identity preservation all along the chain to make sure that if the new variety has been created for a competitive trade, it could benefit the end user that has created it. Last but not least, what I wish to pass you, a message I wish to pass you is to tell you, if it has been decided to go for breeding, continuity is a key. You cannot switch on and switch off every 2 years or 3 years, and especially when you are working with tropical crops and perennial crops. The second question I wanted to talk about, whatever the crop is, if we decided to work on plant science on a certain crop, okay, and in breeding as well, okay, do we believe that genomic could be involved later in the process? I don't think so, because as I said, Genomic is a set of tools for making breeding more efficient, and Guy will explain to you better than me. But what we realized in the past, and what I am quite convinced, is Genomics could offer early deliverable that were not at the early beginning of the project expected for breeding. For example, for sure, you will build some knowledge on the key gene and associated trait. What are the genes that could be involved in certain phenotype and trait? These genomics will deliver markers for early selection in nursery. That is very important because especially for tropical and perennial, it's clear that the field trialing is taking a lot of space. And if you could discard quite a lot of the newly created material already at the nursery, that would save you a lot of space and money. Then genomics is also a way for traceability from plant raw material to end product. And that becomes a kind of quality control tool for the identity all along the chain, for the identity of the variety that has been used all along the chain. And it's becoming more and more important if we want to claim the variety, if we want to brand the product according to the variety. It is also very useful for preservation of strategic genetic diversity, meaning we have a lot of very, very large collection of plants that could not be preserved by seeds. In many of them, there are probably quite a lot of duplicates. And if we could identify, let's say, as we have done in the past, the 50 or the 100, but are covering 95 or 98% of the genetic diversity of a species, that will help a lot to preserve what is core for the future. Then it can be also used for IP enforcement in case of proprietary of the new varieties. And also, if you consider biotechnology, all the knowledge you have built earlier on would allow the company to be at the forefront when this technology will be fully adopted by the consumers, like GM or GE to be adopted by them. I would not enter into this debate, but it is likely that sooner or later, some of these products will come to the market. And if a product company wants to be at the forefront, it has to know what are the genes to be modified or edited. So this is very rapidly the messages I wanted to pass you. And I would be very pleased to give the ground to Guy and then to answer the question I could answer. Thank you very much. Guy, the ground is yours.
Thank you, Vincent. I would now try to follow up in your steps and explain. So if one finally decided to use genomics and breeding for improving his raw material, what can be done and how NRGene can help. So to start, this is a brief history of NRGene. NRGene was founded in 2010, and since then it was developing cutting-edge genomic analysis tools for crop improvements. From the start, it was clear that such improvement exists in many industry verticals and in many crops. And NRGene has been able to deliver projects in more than 200 of them to customers worldwide and covering many different crops and traits. But the more projects we were involved in, the more it was clear that even though some important crops are the source of raw materials for significant industry verticals, in many cases, they lack the basic genomic information for advanced breeding. So if one decides to go for genomic and breeding, he needs to build that kind of genomic information. So to deal with this challenge, NRGene has invested in building the genomic tools that can handle the case of a new crop and build the genomic knowledge base from scratch. In the next slides, I will cover the industries that need such knowledge base building and give some specific examples of projects that would be able to be done by using such a technology. And then I will briefly describe how can we actually do that, using the NRGene app system, and give some very specific example with a specific customer. Great. So NRGene is targeting three main industries. One, of course, is the seed industry, where you're trying to improve seeds, usually to match the demands of growers. In this vertical, NRGene is helping the breeding processes that are also already in place, improving speed, cost, and quality of the breeding decision making. However, in the food and beverages and the natural raw material industries, we are helping to build the genomic knowledge base from scratch sometimes that will allow the buildup of the molecular building blocks or the molecular building system that would be used for the actual breeding. So NRGene has been involved in many different commercial projects along the years. Those projects were dealing with a range of organisms. Such examples are potatoes, berries, eucalyptus, just to name a few. Regretfully, we cannot talk about many of the details of such project because they are proprietary for our customers. So we listed several possible projects that we believe NRGene technology can help significantly in moving forward. So you can see the different types of organisms that can be involved and the different types of traits that such an approach can help provide and improve. How can we actually do what we do? So NRGene has developed a cloud-based AI system that integrates plant performance information from one side and its genomic makeup and from the other side. The outcome of the prediction is an improved variety makeup. What I mean by that is that the system predicts the genomic parts or the genomic solution of the genome that is needed for a better variety to exist, and then predicts what would be the breeding path to get to that improved genome. By able to do this, we can actually cut the time and cost of the breeding process, and of course improve the quality of the outcome, delivering improved variety. However, this process relies on high quality genomic data that, as we just saw, lacks in many of the cases. So what can be done? I'll try to keep the technical details for a minimum, but this is kind of a layer by layer description of how NRGene builds the genomic infrastructure for molecular breeding. We start by building a single reference genome, a single buildup of the reference genome of that specific organism, and then comparing it to other genomes of the same species, understanding what we call the genomic diversity underlying the breeding. Then, over using the diversity, we can build a genotyping mechanism that is usually then used to compare the different parts of the diversity and correlates them with the traits that are needed to improvement. I'll give specific example in a minute, but basically this is the baseline or the basic components to allow prediction of the components that are important to improve specific traits. And then when you do have all the layers that are a part of the prediction process, you can really think of molecular breeding as an approach and deliver a path to over cycle by cycle, improving your breeding and improving the trait to come up with a variety that answers your needs. One great example of such a project is the Bridgestone project. So Bridgestone, the tire company, has taken the decision to diversify its natural rubber sources. It decided to select a new plant for its natural rubber source, and that plant is called guayuli. Guayuli is a natural shrub native to the desert region of southwestern United States and northern Mexico. And it's capable of producing natural rubber and grow on marginal farmland with minimum fertilizers input. Guayuli has the physical and genetic characteristics of a desert plain, successfully tolerating arid environment and making its demand for water lower than other commercial crops grown in the region. However, guayuli was never bred, and no genomic knowledge for guayuli ever existed. So how can such a plant be the target of molecular breeding? So NRGene and Bridgestone embarked on a 4-year collaboration to advance the commercialization of guayuli and build its molecular breeding mechanism. During the project, NRGene has analyzed the DNA of several guayuli plants and mapped the guayuli populations to gather the information correlating the genomic makeup of the guayuli plants and the traits that were needed to improve to supply Bridgestone with better guayuli plants. This is a great example of exactly those steps that I was talking about the slide before. So we were building the first genomes, comparing the genomes to one another to build up diversity understanding, building genetic understanding to build genotyping mechanism, and using the genotyping mechanism to build in the future a possible molecular breeding scheme which can predict what crosses or what breeding path needs to be happening to those guayuli plants to actually improve the traits that Bridgestone was focusing on. So to summarize, planning for robust, sustainable, and high-quality supply chains for plants is critical tasks for many product industries. Breeding improved varieties can be a significant option to ensure such raw material supply. If you decide to go for breeding and genomics, the right use of the genomics and the developing of the genomic information needed for molecular breeding can actually shorten the time and expenses of developing such new varieties significantly. NRGene has proven record of using cutting-edge genomic analysis to support exactly those projects in different industries and different crops globally, and very happy to help future partners in embarking on such projects. Thank you, everybody.
Thank you, Guy and Vincent, for this very interesting talk. We now have a few minutes to take some questions from the audience. The first question is, what are the potential drawbacks of genomics-based inputs for the environment and for food safety and public health? And this question's for Vincent.
Could you repeat the question? I'm not sure I well got it, Tiana. I'm sorry.
What are,
Yeah.
Yes, what are the potential drawbacks of genomics-based inputs for the environment and for food safety and public health? Some of the drawbacks.
Yeah, I understood.
Oh, okay.
I think if we are talking about genomics, I really believe that this is a support for breeding. And it means, I was very often used to say that when we, as a young breeder, before molecular biology, we had to rely only on what we could see in a field. Today, we could rely on what we can see in a field, but simultaneously, and Guy very well explained it, on the genomic makeup of the plant. And I don't see how any drawback of having more information before making the decision to keep this plant and not this one, but making this decision more reliable and faster just because you use these two sources of information. So I don't see any drawback about that. Then if you talk about the discovery engines and gene editing or GMO, that is another debate that I do not want to enter in today. But for sure, genomics as a support for plant breeding, I don't see where is a drawback. And if there is any, I don't see why it would be different from those we could have with conventional and traditional breeding.
Thank you. The next question is also for you, Vincent, and that is, do you think that the current system of plant variety rights based on phenotypic uniformity and stability can hamper a quick and effective improvement of coffee varieties?
You mean among the existing genetic diversity? Yeah.
I'm not sure. This question came from one of our audience members. They said the current system of plant variety rights based on phenotypic uniformity.
Yeah, This is a very good question. Sorry, I did not get it properly. You mean could we use the UPOV system for proprietary right on coffee variety, because this proprietary UPOV system requires this homogeneity and differentiation for sure from what is existing, and stability. So I would say yes, you could, as long as these two main the two main species, Robusta and Arabica, could be both of them propagated vegetatively by cuttings or by tissue culture technology. So then it is exactly like an ornamentals that you could protect. Yes, you could have stability and homogeneity if you are using this kind of propagation, and if you are protecting, I would say, a clone. For sure, it could work. Then it is clear also that clonal plantation might be more risky for diseases sensitivity and so on. So if doing so, you have to consider multi-clonal plantations. I hope I answered the question. Yeah.
Yes. The next question, does NRGene do gene editing for clients, or is it just identifying the genes to be edited or targeted?
Okay, I'll take this one. So NRGene system can definitely identify the right genes that are correlated with specific phenotypes. Now, gene editing is an alternative approach to changing the genetic makeup rather than just breeding it. And of course, in several cases, it could be quicker, more effective, more directed, and so on. On the technological side, NRGene is definitely part of gene editing activity. NRGene is currently participating in an Israel consortium called CRISPR-AL that is focusing on the optimal use of the CRISPR technology in different organisms, including plants. And so NRGene has the capability to design and optimize the use of gene editing technology and approach to specific problems. We're not currently offering a gene editing analysis service, but we are looking for partners, the same as we are doing on the breeding side, so that we can actually work together towards improving significant traits. And for that goal, gene editing will certainly be an approach we are considering using.
Thank you, Guy. Again, this one is for Vincent. What crops would it make more sense to adopt a genomic approach? Vincent?
Yeah.
Okay, this question is for you.
Yeah.
Sorry. What crops would it make more sense to adopt a genomic approach?
It's very difficult to answer, to respond to this question, because it really depends on the business and the product you are looking for. I was used to say that we have to consider plant sciences according to the crop, according to the end product, and according to the country where we wish to develop these end products. So we have to take all these into account. The main message I would pass to you here is the following. If it is a crop that is already very seriously considered by the seed industry, meaning it's not an orphan crop, I do believe that the food industry or the end product company should find a way to deal with the seed company and to ask them, and that does exist already in some cases, and to ask them to develop a variety that is customized for their need. So once again, if looking for tomato, I will not reinvent in a tomato paste company. I will not reinvent the whole tomato breeding. Does not make any sense. But I can go to tomato seed company and ask them to develop something according to my requirements, and I could also help them, guiding them for phenotyping and going even to the pilot scale for testing the product they would have created. So again, I cannot tell you what is the most important crop to be considered. If it is not considered by the seed industry, it's clear that the product company, if they want to secure the supply and diversify the product, they will have to consider it on their own, either in a consortium, as it has been done at the time for coffee World Coffee Research, or alone if it is decided that it is very competitive for the company. Thank you. Yeah.
Oh, thank you. Yes, the next question is for Guy. How shall we approach minor crops with few genetic information? It's not easy for small and medium-sized enterprises to invest fundamental research.
So we certainly acknowledge the fact that the buildup of genomic information requires basically an investment that is not easy for small and medium enterprises. One of the solutions we have found previously is actually doing some of the basic work in a more collaborative way between several SMEs coming together for a consortium. So we have already examples of, for example, of pan genomes of different crops, ranging from canola to tomato and other crops, potato, that in this case was actually even a consortium of commercial and academic institutions coming together to pay for an infrastructure building that then can be used specifically later on for specific breeding needs on a one-to-one basis, meaning that the breeding is not shared by the different entities, but just the buildup of the original infrastructure on the genomic side. So that's one option. The other option that should be considered by SME is always looking on the specific breeding project, because sometimes the actual expense of a very focused project is different from building an, I would say, a general genomic infrastructure. And just for solving a specific trait challenge, sometimes there's a very different cost structure than trying to build something that is general for the crop.
Thank you, Guy. This next one is for you as well. Do you expect to reach the same yield and rubber quality with Wayule as with rubber tree? And if so, in what time frame?
So I can't, of course, give all the details of the project as it is, of course, proprietary of Bridgestone, but I can say that the Bridgestone is focusing on getting very high quality rubber that meets the demand of its internal processing efforts. So the natural rubber is used for very specific needs within the tire companies, and the rubber must meet those needs, and they predict to have the ability to do so. The quality issue is not such the big focus rather than other, I would say, agriculture traits that are needed for actually producing enough of that rubber quickly enough, and I would say in vast enough quantities. And of course, the actual process of the breeding will take a few years, as I explained before, but we are already seeing very nice outcomes that are very encouraging.
We have time for one last question, and this one is for Vincent. How can value chain parties become more sensitive to the importance for quality characteristics governed by crop genetics?
I think I already mentioned that, but you really need this information coming from the consumer and from the processor to go to the breeder. So how could you breed for a better herb or spices or fruit or whatever if the information does not well flow to the breeder? And that is one of the first issues. The second one is for sure to make sure that we have phenotyping tools that are very, very reliable. I would say if you are taking into account these sensory characteristic, and if you want to breed for, let's say, cup quality in coffee, you have to be absolutely sure that the panels of testers you will use for testing the new variety are absolutely reliable, but also are well representative of what the consumer is looking for. So at the end, when looking for coffee and keeping this example, but you could say the same for cacao and chocolate or whatever, you have to set up some, let's say, screening tools, some screening panels that will be in three different layers. One is specialist, one is factory, panels from factory who would be mainly oriented to detect defects. And the third one is obviously the consumer panelist that will avoid the specialist to develop something that would never be accepted by the consumer at the end. So you have to combine all these things. So to summarize, one is for sure to have the good information coming from the end of the chain to the upstream part of the chain. And second, to make sure that the panelists and the screening are capable to do that. If I may just add one word, it's clear that the seed industry has very often been accused of not selecting, not taking into account the quality. And I disagree with that. They wanted to take into account the quality of the new vegetables or fruits or whatever, but it's not easy to screen at every step of the breeding that we have the right sensory profile for a product. And this is where sometimes maybe they failed, but it's not because they wanted to fail, and it's not because there is a negative correlation between, let's say, yield they were looking for and quality. You can have a very good quality with a good yield, but it has to be screened all along the process. And if not being capable to do that, you will lose most of the important traits you were looking for.
Thank you, Vincent. I'm sorry we couldn't answer all your questions, but please note that we will follow up by email to answer them all after the webinar. I'd like to once again thank Guy and Vincent for their time today. Thank you for sharing with us your presentations. This webinar was recorded and we'll have it available in the next few days, so keep an eye out for our email with the link to the recording. We will also have it up on our website. If you have further questions or an interesting research project you'd like to discuss with our experts, please don't hesitate to contact us at nrgene.com. Thank you for joining us today and enjoy the rest of your day.
Thank you.